So our 14th question is find the value of dy by dx at theta is equals to pi by 4 if x is equals to ae, if a is power theta bracket with sine theta minus cos theta, and y is equals to ae theta sine theta plus cos theta. So we have to find the value of dy by dx using at theta is equals to pi by 4 using these x and y equations. So let's jump into the answer. So the solution is, as we have the equation y and x equation, a is equals to e theta sine plus cos theta and a theta sine minus cos theta. So we can just dy by dx is equals to dy by d theta upon dx by d theta, applying parametric differentiation. And so we get this first equation. Now dy by d theta is equals to ae theta cos theta minus sin theta plus में e theta sin theta plus में cos theta. Applying product rule, we get 2ae theta cos theta. Applying product rule, from that we take these two out, that we get 2a theta cos theta. So this is the dy by d theta's value we get, and for the dx by d theta we get ae theta cos theta plus sin theta plus ae theta sin theta minus cos theta. Applying product rule here also, we get 2a theta sin theta. So this is for the dy by d theta, and after that we just simply substitute the values of dy by d theta and dx by d theta in our first equation. From that we get 2ae theta cos theta divided by 2ae sin theta. From this we can cancel this, and this will be 1 by tan theta, which is equals to cos theta, cot theta. Now dy by dx at theta is equals to pi by 4, as we know cot theta at pi by 4 is equals to 1. So we just put the theta in cot theta pi by 4, we get cot theta pi by 4 is equals to 1. So that's the value we get. Thank you.